Hi everyone, welcome back to the workshop, and this is part 2 of the Keithley 2001 multimeter, the 7.5 digit multimeter repair. In part 1 I looked at the digital board and I made some progress with that. I thought I would take a look at the actual display. And the reason for that is I don't trust that this thing is not damaged either. As you would have seen in the previous video, I'll link it down below, the 5V supply in the digital board looks to have gone haywire and it basically wrecked the digital board, so I had to do quite a bit of repair there. Now the display board runs off the same 5V supply. Let's take a look at the schematic. Right at the very top we've got the actual VFD itself. Here's hoping that's intact. I think it should be. And there are actually 4 dedicated shift register ICs used to drive the actual VFD. The whole display board is serial driven. You can see the receive and transmit lines here. Basically these are 4 shift registers, but with the extra capability of driving high voltages on the output, i.e. they're suitable for driving VFDs direct. You can see that we've got a 60V supply on each one of the ICs there, and that 60V comes from the main digital board. You will remember in the last video that high voltage driver board actually had a fault, a couple of transistors faulty, so now I know what the actual voltage should be, 60V. And that 4 MHz oscillator that was damaged on the digital board as well, this is it coming in here from the main digital board. The other schematic is basically just the push buttons which interface to a dedicated microcontroller on the board, and again it is basically serial driven from the main digital board. So looking at the back of the actual board, you can see the 4 driver ICs, the shift registers, and there's the microcontroller over here, and you've got a small ribbon here down onto the main digital board. So the first thing I want to do before I rip it apart, I've got good access to the supply decoupling capacitors on each one of the ICs. I want to go across them with my multimeter and let's see if we've got any short circuits. Okay, so we'll go across this one here first, and great, no short circuit. Yep, so I think this is ground here on this metal tab here, so let's find out. Yeah, that's the 0V there, so I'm presuming the other side of that capacitor there is the 5V supply, or it could be the 60V supply, not really sure. It's probably why you've got 2 capacitors per shift register there, because one will be for the 60V and the other one will be for the 5V. But no short circuits, great. But I'm not just going to leave the display at that. I do want to tear it down. I want to have a look at the other side of the board, and I actually want to take the display board out because I do want to clean this display up, the bezel, etc., and give it a real good clean. There's all sorts of crud down in those banana sockets, and I want to take out the rubber membrane there and give it a good wash, so it will need a good old clean. So let's take the board out. And then the board just comes out. And that is one beautiful VFD. No components on this side here. Everything's basically on the one side of the board. There's hardly anything at all really. You can see it's a little bit dusty, but yeah, that is a beautiful VFD. There's no getting away from that. And then there's the membrane. I'll give that a wash, and the actual front panel itself. Now the front panel is just a mess on the front. I don't know if you can see that in the camera there. I'm not sure if that's going to clean up or how well that's going to clean up. It's almost like it's got a film across the front of it, really. It obviously hasn't. But yeah, it's nothing like the back of it, that's for sure, where it's a mirror finish. That's just a mess, so hopefully that will polish up. The rest of it, yeah, I'll take off this sticker and I'll give everything a good wash. And there's the display all cleaned up. I don't think it's come up too bad. Just a little bit of a pity the screen wouldn't polish up very well. But if the display is bright enough, I don't think it'll be too much of a problem once it's up on the workbench. And yep, everything looks really quite clean. The sticker's gone from the top and the bezels actually come up pretty good. Okay, so the chip I was waiting on coming in finally fitted, and that was the dual channel supervisor IC. So I've got everything fitted that I think I need to get fitted at the moment in order just to get the CPU up and running. And here is the supervisor IC itself, and you can see basically it just monitors the 5V supply, and it just ties into the reset pin and also the halt pin on the actual CPU. So I'd expect to see both of those lines high when the microprocessor is powered up, because they're both active low. So let me reposition the camera, let me get the scope hooked up, and we'll monitor those two lines there. Right, the board is actually powered up, so I'll just go on to the reset line there, and yes, it's high, well, kind of, nearly just under 3V. So I'll just adjust the power. I'll just adjust the 5V down quite a bit. There you go, and you can see it flipped low there because I'm only at 4.3V. Now I'll just increase it back up to 5 again, and yes, it looks like the reset's working okay. So I'll go on to the halt line whilst I'm here. That's this one here, and that one's permanently low. That's not good. So let me just adjust it, turn the power off. There we go, and back on again. Let's see if it flips at all. And it doesn't. That means that the microprocessor is permanently in a halt condition. And I can probably verify that if I go into the bus somewhere on the RAM. High, high, high. Yeah, that CPU is not running at all. Okay, so what am I going to do about that? Well, I've got a little bit of a theory, and that is I'm wondering whether these two proms here are actually blown as well. The 5V supply going haywire, it's probably took them out as well, although they're not hot or anything like that. Now I did kind of anticipate this, like I said, so I actually did order two replacement proms, two AT27C040s, because the schematic diagram does actually mention that they're 27C040s fitted, and these are readily available. So I've bought a couple. They're one time only, they're not EPROMs, they're proms, so they're one time only programmable. And let's go and program these two up, and we'll take it from there. And what I'm going to use for this actually is my new Datamin-40 Pro. I do like the Datamin products. You've seen in some of my previous videos that I've got a Datamin S4, but I've always wanted one of these, and finally I found a cheap second-hand one on eBay, so I've got myself a 40 Pro. And these have a much more extensive database in terms of devices that can natively program through the large ZIF socket on the front there. So let's go over to my PC, let's fire up the software, and let's program the two new proms. Okay, I've got the Datamin software running. First thing I want to do is select the right prom type. There it is, pre-selected there, microchip AT27C040. I'll OK there, and you can see at the bottom of the screen there, it's selected. Next thing I need to do is load the actual bin file, so I'll just load that there. You've got the odd and you've got the even, so I'll do the odd one first because that's at the top. And that's it selected. And now I'll put the PROM into the actual programmer itself, and I will hit the program button at the top. And off it goes. Quite large files, so it'll take just a few seconds to program. Looks like it does a verify at 2 different supply voltages to the PROM itself. And now I'll load up the even bin file. That's it. Now I'll put the chip in the programmer now. And that's it completed. So there we go, I've got the 2 new PROMs here all ready to go, and I've marked them odd and even, and as you can see it's B17 firmware version as a bit of a bonus there to the B16 I've got currently fitted. I was able to find on the XDev site the bin files for the B17 version. So let me go and plug these onto the board and then we'll power up again and we'll see what happens then. And there we go, 2 new PROMs fitted, so let me just position the board ready for another power up and we'll take it from there again. So I've got the scope all ready, so let me just put power on and we'll go down on the reset pin again first of all, and that's high, that's good, and the halt pin is also high, excellent. So let's go down onto the bus on the RAM here and let's see what it's doing. Ah, look at that! We've got something. And that's unmistakably like a data bus or an address bus that's just running away rather nicely, and just scoping various random pins there. That's looking good. I think the CPU's up and running no problem. Now the CPU does have a built-in watchdog, a software watchdog, and if the program crashes or it comes across any problem it will do a self reset. So going back onto the reset pin again, it looks like it's permanently high there, so I would assume that the program is just running away perfectly. No problem. Now the next thing that I want to do, I really want to plug in the display and see if we get anything on it when I power up the main processor there, the main digital board. And I have actually gone ahead and measured across the various caps and I've not got any short or anything like that on the display board. So whether it survived, I don't know. It does have its own microprocessor, so I hope we don't have to buy a new one of them and reprogram them, not to mention replace any of the other chips. So here's hoping that this works, and this basically just plugs straight onto the digital board. Now I'm not actually too worried about if there's a problem with the 5V supply on this board here, that I could maybe overload my 5V supply, because I'm not using the regulator again. I'm still connected to the bench power supply where I can monitor the current consumption, etc. So I'm not too worried about that. But wait a minute, I can't plug this in just yet. I've still got the high voltage generator board to plug back in. I have actually changed the transistors on it. I've got 2 new transistors. I actually replaced them with the exact type of transistor that was on it before, the 2N6715 I believe it was. So I believe this is ready to go back onto the main digital board, and I should be able to measure the high voltage connection there and see what it's doing. So I've got the board soldered in now, so let's put the meter on it and see if we're getting our 60 volts. So there's the Just put power on now. And we're getting 58.3 volts. Perfect. Now I don't want to just simply plug this into 5 volts assuming it's okay. You know, the only connection down onto the main board is through this ribbon cable here, which connects in over here. And I don't really want to just plug it in and hope for the best. I know there's no dead shorts across the various ICs, but I think I'd rather put 5 volts into it straight from the power supply on its own, and let's see what sort of current consumption we're getting on it without the 60 volts active, of course. Well, off camera there, I hooked it up and I believe it was drawing just about 10 milliamps or something like that. So not really sure what's going on. Certainly there was nothing on display because I just had the 5 volts. There was no 60 volts, etc. But I just think we've got to bite the bullet. If it was only drawing 10 milliamps, I think we can plug it into the main board and see what happens. But I've got control over the constant current mode of the bench power supply, so we're in good control. Okay, we're ready for a power up. Everything's hooked up. And I think we're ready to go. I have actually verified that I'm getting a 4 megahertz clock from the new Epson oscillator I'd fitted here, which basically just goes direct to the header for the display board, and it's present, so there's no problem there. I've got my 60 volts, got my 5 volts through the board onto the header as well. I'll increase the bench power supply and let's see if we can get 5 volts into the system now. So the power supply is off camera, so I'll just adjust that up and see what happens. Yeah, we're up about 4.6 volts at half an amp there. And there's 5 volts now. No, it's dropped down to 600 milliamps now. No, I don't think that's right. It's too much current consumption there. It's only a 1 amp regulator that's fitted, so something's not right. This display board's drawing far too much power. So let me just power it up again and let's see if we're still getting the 60 volts. I presume we are, because we did get something there on the display. What I'm thinking at the moment is that we've got some faulty ICs on the display board, and I think probably the first one I would look at would be the actual microprocessor on the display board. So I might need to order something up for that. Right, everything's hooked up, ready to go again, so I'll just probe that and I'll just up the power supply and see what we get. Yeah, we're definitely achieving something like the, I mean, I'm only at 3.7 volts and I'm getting 36 volts already, so I think the 60 volt supply is okay. Let me just turn it off again. That's 600 milliamps. That's just far too much for the display board. Now, what I'm going to do is I'm going to make up a header for here, for where the display board plugs in, but I'm going to miss out 3 of the pins, and that's the 5 volt supply from the main digital board to the display board, and I'm going to use my other bench power supply just to power the display. So everything else will come through the header except the 5 volt supply. There's only 3 of the pins there which supply the power to the display board, so it should be okay, easy enough to hook up. So let me go ahead and set that up. Okay, so here's what I've done. I've hooked up the header jumpers from the main output here to the display board up to the display header, but I've got the 5 volt supply that goes away off the display hooked up to another power supply, and I've got the ground connected as well. I've powered up without the 5 volt supply to the display board running, and the digital board is drawing all the power. It wasn't the 5 volt rail on the display board that was drawing all the power, it was the digital board, and only when I've got the signals hooked up between the two. Now here's the digital board schematic. Here's the header, that all 16 connections that go to the display board, and all you've got is a system reset line, a couple of comms line that's receive and transmit. You've got the 4 megahertz oscillator here, which I know is working. It goes away off to the display board as well. You've got the 60 volts connection from U625. You've got 5 volt and you've got common. So something on this header is drawing all that extra power. Now I don't think it's the 60 volts because I did measure that and it seemed like it was okay. Now I doubt it's a 4 megahertz oscillator signal there. It's not the 5 volt supply. We've got that disconnected. The only thing it leaves is the reset signals, the receive and transmit, but it can't be them. And here's the display board. Here's the same 16-way header. You can see the 4 megahertz signal coming in, the receive, the transmit and the system reset signals. And there's the 60 volt supply coming in pins 9 and pin 11. But wait a minute, I'm dreaming. I missed 4 other pins on the actual display board connector here. You've got 4 and 6 which are tied together, and 14 and 16 which are tied together, and they go a way off, and I presume they are the filament supply for the actual VFD. And looking at the schematic for the small high voltage board that I'd made earlier, of course, here's it here. You've got an 8.2 volt center tap here, and these are the 2 lines of the filament supply directly to the LCD. So I need to check, first of all, whether we've got an 8.2 volt supply on the main board. And there's the 8.2 volt Zener diode there, which is connected to pin 2 of the U625, which will be the center tap of that transformer. So I need to measure that. Let's see, we've got an 8.2 volt supply. So I've got the header disconnected at the moment. So let me go on to there, and let's just off camera, I'll just up the power supply. Should be able to run it properly at 5 volts now that I've got nothing connected to it. And I am indeed getting 8.2 volts. So there's no problem there. So the next thing I'm going to do is I'm going to disconnect that filament supply from the header here and run it at that and see what happens. And there we go, filament supply disconnected. So let's try that again. Off camera, just up in the power supply. And yes, I can get 5 volts, drawing about 380 milliamps. So power supply back down again. So what I think I'll do now is I'm going to put back the 5 volt supply to the display board back from the main board, and I'm going to power it up without the filament supply to the display board. So let me go and hook that up. Okay, here we go. So the only thing that I've got disconnected now is the filament supply. So let me try the 5 volts now. Off camera, I'll just up it, see what happens. And I've got 5 volts, no problem. And of course I've got nothing on the display. We've got no filament supply. But I'm achieving 5 volts across the board. And we're drawing about 400 milliamps on that 5 volt supply, powering everything here. So what's the problem? Well, I don't know that there is a problem. The ICs on here are all powered up, 5 volts to all them. The only thing that's missing is that filament supply. So is there a surge at startup that I'm not managing to get over because I'm up in the power supply 50 milliamps at a time? Am I going up too slow? Do I need that surge at startup for the VFD filament supply? Because we've got the 8.2 volts. I know the little transformer's intact, but somehow or other the filament supply is drawing far too much current. And what worries me a little bit is, could it be that the filament on the VFD is the source of all the problems? Could it be drawing far too much current that it eventually blew the 5 volt regulator on the digital board and caused a cascade of failure when every IC on the board saw basically the incoming unregulated supply? I don't know. I can't take the chance of fitting a 5 volt regulator anyway, but I could just take the power supply out of constant current mode and whack the power in and see what happens, but I don't know, it's a bit too much of a chance to take. But I know the filament supply was working because we did get some dashes along the display here. And now I know it wasn't a proper readout, it was just some random dashes, but that's because I hadn't achieved 5 volts yet on the main digital board. It was way down at 4 volts or something like that. So the CPU on the digital board hadn't actually started up yet. So there was no comms over to the display. Okay, what I'm going to do is check out the resistance across the filament. Now this is a pair here and that's the other pair here. They're actually joined together to the header. So if I just go across any one of these to any of the other two, oops, there we go, 6.7 ohms. Well, 6 ohms across the filament connections on the VFD isn't that far out. I believe a general filament resistance impedance is about 10 ohms, so without a second display it's really hard to tell. And I still don't just want to whack in 5 volts with a high current limit just in case. So I think what I might do is reconnect up the filament supply, put a couple of series resistors on them just to limit the current, and let's see if I can get 5 volts on the digital board running and the display board hooked up with at least some sort of filament supply there that I might be able to see what's on the display. And we've achieved 5 volts. I've got some series resistors in and I can just see the VFD and no more. However, it's not running. I've just got a bunch of dashes right along it. So what I need to do now is scope the serial data lines from the main CPU to the display and let's see what we're getting. And as I showed earlier, here it is here, we've got 3 lines. We've got a system reset line which comes directly from supervisor IC, and then we've got this RX and TX there. At the moment I don't know which way round they are, but let's scope these two and see what we're getting. Okay, so power's off at the moment, so I'm going to scope one of them here on R603, which should be the microprocessor side, and at the moment obviously it's 0 volts, I've got no power, and I'm just going to up the power supply a bit at a time like I've always been doing, and you can see it comes up there and you get some comms there just for a fraction of a second and then it stops and stays high. So let me do that again, back down to 0 volts again, and I'll up the power supply now, and you can see it climbing. Oh, it's my scope probe, and you can see that comms there just for a fraction. Now I want to do the same on the other side. I'm on the other resistor now, and I'll just up it slowly. Got something there, but the voltage levels are pretty bad. I'm at 5 volts now and I'm showing 2 volts there. That is not right. Definitely a problem there. I'll try again. 0 volts. Now start climbing. No. Try adjusting the scope a bit. One more time. Back down to 0 volts. And up we go again. I'm not sure what's happening there. So I was measuring R604 there in the scope, and that's the problem one. So I need to find out whether that's the receive or the transmit from the display board of the CPU. And looking at display board schematic, here's the CPU, and you can see TXB, that's the one that's working. That's comms from the main CPU up to the display CPU, and that's working. As you can see, I've signified with the arrows of direction there because it's not always easy to tell. And here is the output serial comms, coming out and going away back to the main CPU, and this is the problem one. So it looks to me that there's a problem with this CPU. I'm not really getting much on any of the pins at all, and I know I've got a good 5V supply. I know I've got a good 4 MHz oscillator signal. Everything looks fine. It's just not doing anything. It's basically dead. And the fact that I'm getting something like 2 volts or some odd kind of signal coming out of that serial data line, I would be expecting to see something coming out of there. Maybe all the time, but maybe only on a press or something like that. But I would expect comms all the time, to tell you the truth, and I'm just not getting anything at all. So I think that CPU's dead. Now, I have ordered a new one. The big problem I've got at the moment is I can't find the firmware anywhere for it. So if anyone out there knows of an available display board or firmware bin file, whatever, get in touch with me and we'll try and take this Keithley 2001 to the next step in terms of its repair. Thanks for watching.